So our definition of a system of equations is two. I'm going to have you write in parentheses or more, and we'll go back to that later. Two equations with the same variables considered at the same time. So if I just summarize that, our goal of these questions, of these systems of equations, is to find the x and y that make both equations true at the same time. And we have three methods we're going to learn to solving systems of equations. The first one is going to be to solve by graphing. The second method is to solve by substitution. And our third method is to solve by elimination. So just focusing on solving system equations by graphing. To solve by graphing, it's going to be a two-step process. We're going to graph both lines. And then we're going to tell the point where they cross. And that ordered pair will be our answer. So if we look down here at example A, we want to solve the system by graphing. So first thing I want to do is graph this line y equals 3x. I'm going to go ahead and write a plus 0 to make it obvious to me the y-intercept is 0 and my slope is 3. So from that 0 I'm going to rise 3, go over 1, rise 3, over 1. I'm also going to go down 3 and back 1 just to make sure my line is perfect, because precision does really matter on these. Next, I'm going to connect those points with a straight edge. Now I want to go ahead and graph this second line on the same coordinate plane. My y-intercept of 5, my slope of -2, so I want to go down 2 over 1, down 2 over 1, continue this to the edge of the graph. Looks like at that point I have enough points to connect. Use that ruler again. Precision is so very important on these ones. And let's see, it's very obvious where my lines intersect at this point right here, which would be the coordinates 1, 3. So our next example, example B, is a little more difficult because before we can graph them, we're going to need to go ahead and get y alone. So I'm going to look at this top equation, my 3x plus 2y equals -6. Before I can graph that, I'm going to want to get it into slope-intercept form, so work to get y alone. Subtract that 3x, 2y equals -3x minus 6. Divide by 2, still working to get that y alone. Y equals -3/2 x minus 3. So I'm going to plot that line now. Start at y-intercept of -3 and use that slope of -3 to go down 3 over 2. Just about out of space there. So I'm also going to think of it as up 3 and left 2, up 3, left 2, up 3, left 2. Go ahead, grab that straight edge and connect them. Again, I need to graph my second line, x minus y equals -2. I can't graph it until I put it into slope-intercept form, so work to get y alone, subtract x from both sides, and still work to get y alone, divide by -1. Y will equal positive x plus 2. Y-intercept of 2. Slope, there's nothing there, so we want to assume it's a 1. And 1 as a fraction is 1 over 1. So up 1 over 1, up 1 over 1. Or we could have gone down 1 and back 1. There's quite a few of those, enough to connect them. with that straight edge and find our point of intersection is back to up 0. So -2, comma 0. Flipping that page. So looking at example C, before we can graph that, we're going to have to do a little bit of work to get our y's isolated. So looking at that top equation, 2x minus y equals -1. Let's subtract 2x from both sides. -y equals -2x minus 1. Still working to get y alone. We'll divide by -1 to get y equals positive 2x, positive 1. Y-intercept of 1, slope, we think of as 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, down 2, back 1. Connecting those with your ruler. Moving on to our second equation, 4x minus 2y equals -6. Before we can graph it, work to get that y alone. So subtract 4x from both sides. 2y equals -4x minus 6. Divide everything by -2. Y equals positive 2x, positive 3. So our y-intercept of 3, using that slope, up 2 over 1, or down 2, back 1. Quite a few of those points. You can connect those now. And something interesting happens here. Our goal was to find the ordered pair where they intersect, but these lines don't intersect, which means there is no solution because they are what type of lines? Parallel lines. And our last example, example D, again looking at what we're given, 2x plus 2y equals 4. We can't graph that till we get y alone, so let's subtract 2x from both sides. So I've got 2y equals 2x plus 4, dividing each term by 2. Y equals -x plus 2. Y-intercept of 2. Slope is telling us to go down 1 over 1. Or we could have gone up 1 and left 1, up 1, back 1. A couple of those. Connect them with a straight edge. And now let's look at that second example we're given, 3x plus 3y equals 6. Again, can't graph it till we get y alone. So let's subtract 3x from both sides. 3y equals -3x plus 6. Still working to get y alone, divide by 3. Y equals -x plus 2. Y-intercept of 2, slope of -1, down 1 over 1, down 1 over 1, or maybe up 1, back 1. This should seem pretty familiar because you graphed the same points, you connected them, and traced over that same line. Let's go back, going back to our question, where do these lines intersect? Well, they intersect everywhere, all over the line, which would mean there are infinitely many solutions. There are infinitely many ordered pairs where those lines intersect.